Now, I'm just going to use this very simple function, cosine of x on 0 to pi over 2, just this very simple piece of the cosine curve. And we're going to talk about some of the properties of the integrals here. So let's do this. So first off, let's just find that integral, the integral from 0 to pi over 2, cosine x dx. And then we'll talk about the interpretation, and then we'll go through a few other computations and sort of get a feel, get a little bit better handle on what's happening here. So first, just the computation. Well, this is the fundamental theorem of calculus. We need to find an antiderivative for cosine. And so the antiderivative of cosine is sine plus constant. We're choosing the constant to be 0. So we have sine of x, and this is evaluated from 0 to pi over 2. So this is sine pi over 2 minus sine of 0, which is 1 minus 0, which is 1. So the area, one of the interpretations is the area of this region is 1 unit, 1 square unit. All right? Now, let's illustrate this property. According to the property I showed, all we've done here is interchange the limits of integration. Which means if I told you the right thing in the previous video, this should work out to be the negative of the answer we got here. This should work out to be -1. Well, let's see if that's what happens. It's stinking better be what happens, because the antiderivative of cosine is still sine. That hasn't changed in the last few minutes. But now this is being evaluated from pi over 2 lower limit to 0 upper limit. And the fundamental theorem says you evaluate at the upper limit minus evaluate at the lower limit. Upper limit minus lower limit. So now this is sine of 0. This is now sine of pi over 2. This is 0 minus 1. That's -1. And so, again, that doesn't prove anything, but this is an illustration of this property that says if you interchange the limits of integration, the value you get is the opposite of what you've gotten before. So if you accrue area, if the area you gain is going from left to right, starting at 0, going up to pi over 2, then that will accrue from left to right. That will be interpreted as a positive number by this computation. On the other hand, if you start at the right and go to the left, start at pi over 2 and go to 0, now we're doing this. We're starting here and coming in that direction. That will be interpreted as a negative value by the computation. So when that happens, if you need to understand that that's what's going to occur because you've interchanged the limits of integration. All right? Now, the next property we're going to illustrate is this. This should be pretty straightforward. Let's do the integral from pi over 2 to pi over 2. Well, if there's any justice in the world, this should work out to be 0 because that's what the property says. And there is justice in the world, and it does work out to be 0. Let's just actually verify that. The antiderivative of cosine is sine, and that's evaluated from pi over 2 to pi over 2. This is pretty obvious here, isn't it? This is sine pi over 2 minus sine of pi over 2. Well, that's got to be 0. And it's not hard to see there's nothing magic about cosine. There's nothing magic about pi over 2. This is not a proof. This is sort of essentially an illustration showing that property in action. Essentially, a more formal proof, if you felt led by the Spirit, you could do a little more formal proof. Well, you know this is equal to cap f of x, but this is evaluated from a to a. And so the fundamental theorem that says this is cap f of a evaluated at the upper limit minus evaluated at the lower limit. And so that's not very hard to demonstrate that property is correct. That actually is a proof of it. But this is one of the this is that property in action here. So those are the first couple of properties sort of play with this particular function.